What's good, guys? Today we're going to go ahead and solve a minimum stack. So basically, this is the design problem where we have to design the minimum for a stack. Let's see. You can go ahead and put my laptop down, figure this out. All right, so we have to design a stack class that supports push, pop, top. What does top do? And get minimum. Okay. So minimum stack initializes the stack object. Okay, so let's go ahead and get that min stack. Okay, initializes. Okay, so what kind of um okay, so min stack, push one, push two, push zero, get min, pop, top, get min. Okay, so we see that void push pushes the element val onto the stack. Void pop removes the element at the top of the stack. Int top gets the top element of the stack, removes the element on the top of it. So I guess int top gets the top element of the stack, but doesn't actually pop it, right? But void pop removes it, so it does pop. Get min retrieves the minimum element in the stack. So would that be the smallest number in the stack? I think so. And let's go ahead and try to implement this now. So when you do min stack initializes the stack item, let's just say that would be this one right here. So it'd be stack is equal to stack dot self dot stack. So I'm saying that stack self would be a I guess it's hmm, stack say min stack is equal to self dot min stack. Okay, so that's the first one that we would do. Go ahead and check out the second operation. Let's see. Oops. There you go. And then push. It doesn't return anything. It just kind of just adds to the top of the stack. So that'd be min stack. Um Actually, how do I initialize it? I would say min stack is equal to stack. Isn't just a regular stack. Isn't that just like this? Shouldn't there be a self though? All right, whatever. I'm just gonna say that. And then pushing to the stack would be stack dot push. And then we just put in the value over here. Okay. And then pop would be stack. Well, pop doesn't return anything, does it? Let's see. Removes the element at the top of the stack, so it doesn't really do anything. So I'll just do stack dot pop and define top would get the top element of the stack. Okay, so I'd say stack stack at this negative at -1. That'd be the one at the top because it's the latest one that was added. Say return. Um, what would it kind of confused on what it would say? Hmm. So push one would push one on stack. Push two would push two on the stack. Stack three push zero. Get minimum. Pop pop. Okay, now get the minimum. We get the stack. Okay, let's go ahead and just try to get the minimum. So minimum could be if it's, I guess you could have the smallest number. Each function should run you could use a stack. Another stack. If the element is hmm, this And if we push the val is greater, less than. That's gang. Gang back back. You can tell by his voice. If value is less than minimum stack, then we go ahead and push it onto it. We could just say equals well. That's fine. No, let's not. Okay, if value is less than min stack at -1, then we go ahead and append it. Min stack, we could say min stack dot append. Eh, I could say this min stack dot push. I'll say append. Append val. Yeah, we could have that. Then we go ahead and just return get min. Just return min stack at -1. Yeah, okay, we could go ahead and do that. I think this should be everything. Um, okay, I think this should work. I'm pretty sure there's some sort of syntax area. MinStack says no stack. Guys, go ahead and look it up. Push. Let's push do. Like he stopped by. Maybe stopped by for a little bit. All right, I'm gonna go upstairs then. Bum, bum, bum. All right, let's see. My pop method says, but we never update min stack when popping. When you push in duplicate minimum values. Ah, okay, I can see. Yeah, okay, so we should actually put this as equal. Um, hmm, less than or equal to. Also, we should update the min stack when we do pop. We should also do self that min. How do I pronounce it? Min stack. Dot pop. Pop that too. I think this should work now. I'm gonna go ahead and submit it. And we got an error right here. Okay, let's see. Yeah, okay. Get the minimum of the stack. Let's see. If not self dot min stack, then we just return none, and else. We could just return this because then we could safely assume that we have seen something in there. Let's go submit it, and this should, huh, min stack. Well, how do I pronounce it? I went with min stack. This with the capital S on the end. And let's go ahead and do that right here. Oops. And let's fix that. And let's go ahead and submit it. And we ran into an error. Okay, let's see. Um, your output was min, but expected return none. Get min should return. Well, let's see. What if we try to call something? Does it say right here? Pop, top, and get min. Well, if it's always called on non-empty things, then we should always assume that we could actually get the bottom, right? Non-empty, yeah. I think this should be able to work. I don't know why it's not. I mean, if we could assume out of range, how's it out of range? Does it not have a last one? All right, whatever. Return. We could just say return. Yeah, just call it self. Return top min stack dot pop. No, that top. Return top min stack. Shouldn't this work? I don't know. Self dot top. I don't know why it's out of index. Self dot top. Hey man, whatever. It should be this though. I'm confused why it's not this. All right, I'm confused why it's not. I'm confused why it's not that, actually. Assume that every push adds to both stacks, but that's not true. Mm. Let's see. What's pop do again? See, pop removes the element at the top of the stack. Yeah, that should work. What are you talking about? Mm. I even do that. That shit even allowed. One. Hey, that's not bad. Okay. Okay. Self.min stack. I gotta capitalize that S. Typical mistake that I keep on doing. And we finally solved it. Okay, this question was actually not too hard. I'm not sure if I solved it the most optimal way. Let's go ahead and look at. Okay, let's go. Oh shit. Okay, let's go ahead and look at the solution, see how it differed. Brute force was by using oven to get min. Okay, two stacks. Ah, yes, I think I used that. Push all stores, stores maximum so far at each level. One stack. So one for every operation. Kind of just solved that. Oh, they're very similar. Oh, okay, let me see. One stack. It stores encoded values instead of actual numbers. Wow, interesting. The trick is to record the difference between the push values and the current minimum. Whenever a new minimum is pushed, we store a negative encoded value, which signals that the minimum has changed. Later, when popping such a value, we decode it to restore the previous minimum. This way, the stack internally keeps track of all minimum updates without needing a second stack. Wow, that's crazy. What the fuck? So we push, if not self stack append. Whoa, that's some advanced level shit, yo. Hey, I might have to learn that later, but I'm gonna try to just learn my fundamentals first before working on the one stack method. Hey, I want to really look that up, but always gotta apply for jobs study, so maybe not. Well, thank you guys for watching. That was me solving MinStack. MinStack wasn't too hard. I actually like this question. It didn't seem like a medium. I guess I had to go back and forth with the GBT. That's just because I kind of had syntax issues. But this is pretty not too bad. I'm gonna try to solve this again later. maybe more smoothly now that I know the syntax. Yeah, cool.